So today what we will be looking at is substituting, or if you want to think of it this way, just simply plugging in. Here we have a problem that we'll begin with. It's a very easy and simple problem. It's x plus 11 equals 14, and we're given x equals 3. And the goal is to plug in x's value, so in this case x equals 3. And when we plug this in for x, we want to see if the equation is true. That is, that the same number is on both sides of the equal sign. So we'll go ahead and get started. I will rewrite the equation here. We have x plus 11 equals 14. And we're given that x equals 3. And again, we just want to check if 3, when we plug 3 in, if that gives us a true equation. That is, both sides have the same number, the same value. So step number 1 is going to be replacing the x. Now I'll start off by just simply rewriting the same equation. X plus 11 equals 14. But now we want to send the x home. That is, we're going to take the x, place it where the 3 was, and we're going to substitute it for the 3. That is, we're plugging in the 3. So now we get 3 plus 11 equals 14. Now, step number 2 is to combine these two numbers because they are now like terms. They're the same. So we have positive 3 plus 11. This means a positive 11. And 3 plus 11 is 14. We keep the equal sign the same. We keep the 14 the same. And we get 14 equals 14. We have the same value, the same number on both sides of the equal sign. So that means this equation is true, which means that 3, so when we had this 3, that is a solution to the equation because it made it true. Great, so now we will go on to the second problem. And this one's a little harder, but it's still relatively simple. So we have 2x plus 3 equals 15. And we're given x equals 6. And again, the goal is to plug in 6 for x, simplify and solve the equation, and see if the last line is a true equation. Okay? So I'm just going to go ahead and rewrite this as we did earlier. And note, I have this 2x on a separate color because it's a different term. It's together. You can't separate those that easily. It's not individual like a 3. So if we have 2x, and remember 2x means multiplying. Remember, this is another way of showing multiplication. So 2x means 2 times x plus 3 equals 15, and again, x equals 6. So if you remember from the last problem, our step number 1 in the end is going to be to substitute the 6 for the x. But first we'll start off by just rewriting the problem. 2x plus 3 equals 15. But now we want to take this x, send it home, and plug in the 6, substitute it. So we're just going to replace it, put the 6 right there, and remember, it was 2 times x, but now it's 2 times 6. It's not 26, 2 times 6. So now, the next step is to combine. So we want to combine like terms and do our PEMDAS operations and everything. And here we have 2 times 6. We want to get rid of this thing, this purple term. That way we get one clean number. So we'll go ahead and do that in our step 2. 2 times 6 is 12. And everything else will just stay the same. 12 plus 3 is 15. At this point, you might already be able to see the answer, but we'll just finish it. So now we can combine these two because they're both numbers. They're the same, they're like terms. So now step 3 is combining these like terms and just simply getting to a one line equation where there's something on one side and one thing on the other and seeing if it's true. So 12 plus 3 is 15. We carry that equal sign, and we carry the 15 down. We've never touched any of this. 15 equals 15. Well, that's true. So that means that 6, when we took the 6 from x, that is a solution to this initial equation. That is, if we plug in 6 for x, that will make this true. Great, so for this problem, I went ahead and set it up, just because it's a little more complex. But this is what we will be solving. Negative 9x plus 3 minus 2x equals 14. And we're given x equals negative 1. And again, the goal is to plug negative 1 for x and see if, when we simplify it, we get a true equation. So our first step, we want to get the x's together. These are both purple, these are both like terms. They're both 2x and 9x, or negative 9x. They're both a number and an x, so we can actually combine those. And the reason we want to do that is because while we can take this negative 1 and plug it in for both of these x's, if we had, 100 x's, that would be too much work, too much plugging in. Instead, we want to get them to 1x to combine them, and that way we only have to plug it in once. So we'll go ahead and do that. I'll rewrite the equation. I'll just kind of swap these so it's clear what we're doing. Since they're like terms, we can do negative 9x minus 2x. And I will use a number line just to demonstrate this a little bit better. But if this is your number line, and you're here, let's say 0 is right here, and you have negative 9 minus 2x, so you're going this way. Remember, this is negative, this is positive. So to subtract 2 means to go 1, 2. We're at negative 11. Great. So I will take this. Negative 9x minus 2x is negative 11x. And the rest of the equation is the same. Plus 3 equals 14. Great. So for step number 2, it's what we've been doing all along, is the actual substitution. Now we only have 1x to replace, so it's easier to just replace them. Send that x home and bring whatever's there in for its spot. So I'll just rewrite it. Again, negative 11x plus 3 equals 14. But now, again, remember, negative 11x means negative 11 times x. Now we want to send this x home. We're going to send him with his x. And whatever was inside, we want to bring it out. So in this case, it was negative 1. So we'll take this negative 1. And now we have negative 11 times negative 1. And I'll scoot this up just because we have a little more work to do. Now, step number 3, we will combine this. We will do our multiplication to get one number, which we can then add to our other number. So negative 11 times negative 1, remember 2 negatives make a positive. So this becomes positive 11. And then everything else stays the same. 11 plus 3 equals 14. And now it's clear we can combine these two. 11 plus 3 is 14. And that equals 14. So yes, this is true, which means that negative 1, what we originally had here, we put here, negative 1, does make this equation true. So it is a solution. So far, every problem we looked at had a correct answer. That is, when we plugged in x, it gave us a true equation at the end. However, this is not always the case, and in those cases, it's fine. We will be looking at 6x minus 3 equals 11, and and we're given x equals 2. So again, our goal is to plug in 2 for x and see if we get a true equation. So here we have 6x minus 3 equals 11, and we have x equals 2. Remember, 6x means 6 times x, and it's simplified to the best of our ability. We can't combine like terms right now on this side, so we're just going to leave it as is and jump right into step 1, which is plugging in the 2 for the x, or in other words, substituting. So again, what we've been doing, I'm just going to rewrite the problem. 6x minus 3 equals 11. But we're going to swap the 2 and the x. We're going to do that substitution. We take x over here, we send it home. We bring the 2 out, and now we get 6 times 2 minus 3 equals 11. So that's the first step. Our second step is now we can combine the 6 and the 2 to get this into one number and get rid of this purple part. And that way we can have two numbers that we can combine. So we have 6 times 2, which is 12. And we have the rest the same. 12 minus 3 equals 11. Our final step is to combine these two numbers and see if it matches what's on the other side. So 12 minus 3 is 9. 9 equals 11. And we know that 9 does not equal 11, so this is not true. In other words, x equals 2 is not the solution to this equation. It does not make it true. Therefore, it is not a solution.